Question 17. Here is a rectangle. Area equals width times length. So we're basically looking for 6 times 4. Tables knowledge here, not going to go through that too much. 24 is the answer, C. Question 18. Which quadrilateral has exactly one pair of parallel sides? Must have exactly one pair of parallel sides. I like the word parallel because it's got 2 L's in it, which look like parallel lines themselves. It's a great way of remembering it. Okay, so a parallelogram is like a knocked over rectangle. And it has, I'll just re-sketch that one here. It's like a knocked over drunken rectangle of some sort, slanting, wobbling over. We have got 2 pairs of parallel sides on this one, 2 going kind of diagonally upwards and a couple going acrossways. A rectangle like a parallelogram also has 2 pairs, those 2 there and the 2 going acrossways. A kite has no pairs of parallel sides because these lines always meet at some point, if you imagine them continuing. A trapezium is the shape we're after because that only has 1 pair of parallel sides, and a rhombus is what I call a drunken square, wobbly square, all falling over, and so on and so forth. So that's got 2 pairs of parallel sides. Make sure I get my symbols right now. So the answer we're after is D, trapezium. 19. The nth term of the sequence is 3n plus 5. What is the 6th term of the sequence? So if I just want to answer this question without making silly mistakes, I need to remind myself that 3n is basically the 3 times table. 3, 6, 9, 12, 15, 18 and so on. 3n plus 5 is going to be 5 added to each of those numbers. So that's going to be 8, 11, 14, 17, 20 and 23. And you can see each time they're still going up by 3 each time. So that helps me to check that I've done the right thing. It's basically the 3 times table with a plus 5 adjustment. This is after the 6th one. So 1, 2, 3, 4, 5, 6. We are after this number here. That's the 6th number in the sequence. So we're after 23, D. Okay, question 20. What are the coordinates of the midpoint of the line joining P, 3, 4, X? This is the X value, and that is the Y value, and Q, where Q is 5 across and 8 up. So what I really want to do here, just maybe write these above each other. There's P, and there's Q. And when we're being asked to find a midpoint, we're basically finding somewhere in between, exactly halfway in between. With this being the X and the Y value, we just kind of look at the X values first of all, and then we'll look at the Y values. We need to find halfway between 3 and halfway between 5. So that would be 4. For the Y value, we're trying to find halfway between 4 and halfway between 8, which is 6. So we're looking for 4, 6, which is D. 21. Pens cost 10p each. Pencils cost 12p each. What is an expression for the total cost in... I'm going to colour code these. Okay, there we go. What is an expression for the total cost in pence of X pens? So we're talking about pens which are red, and Y pencils. So I'm going to get my colour coding going on there. That'll be rather useful. So what I'm looking at here is I'm looking for the Y that goes with the 12. Okay, that works there. And I'm looking at the 10p that's in some way connected to the red or the X value. So that would be that one. So that makes E our answer here. So in terms of helping us think think how this works. If I had 2 pens and 4 pencils, then I'm going to have 2 lots of 10p, which is 20p for the pens, and 4 lots of 12p, which would be 48p. So altogether that would give us an answer of 68p. We can check if we've ticked the right one here by just substituting in those values. 10 lots of 2 plus 12 lots of 4. And we can see there I've got 20 plus 48. To help kind of disprove the other ones, C looks really similar to E. If we tried this the other way around, and I had my 2 pens, I would have 24 plus 40. And that would give us a different answer of 64p, which would be wrong. This kind of matches to this one here. So that's sometimes useful to substitute in a value to check and see if things work if you have time. Okay, last few questions here. 22. Here are the first 5 terms of an arithmetic sequence. Arithmetic sequences normally have a continuous progression which is the same common difference each time. Again, every time I see a sequence, I'm writing the difference in each time because I know this is going to be useful for me probably at some point. They're going up in 4s each time. What is an expression in terms of n for the nth term of the sequence? Now, before I've even read that, I'd already put all my numbers on the page. So I know it's definitely going to be 4n because it's something to do with the 4 times table. If I can see any of these that don't have a 4n, I'm instantly crossing it out. So I'm left with, I'm now left with a 1 in 3 chance of getting it right. What I can do is I can automatically rule out E. It isn't 4n because this is not our 4 times table. These numbers are different. Our 4 times table would be 4, 8, 12, 16, 20 and so on and so on. What you can notice each time that the sequence we've been given is 1 less than the 4 times table, so the one we're after is 4n take away 1 each time, which would be that one. We can double check this by substituting in an n value. The first term is when n equals 1, so 4 times 1 take away 1, so that would be 4 take away 1. So the first number should be 3, which it is. And that allows me to check that I've got things right using a bit of substitution. Okay, question 23. What is 72 written as a product of the prime factors? Now, first things first, this prime factors vocabulary here. If you can see any numbers that aren't prime numbers, then automatically you can rule out those. You can rule out those possible answers. 8 and 9 are not prime numbers because they have other values that go into them other than 1 in itself. They have more than 2 factors. 2, 4 and 9. Again, we've got 4, that's not a prime number, and neither is 9. They've got other factors that go into them other than 1 in itself. Likewise, it's not B because it's got 1 in it, and 1 is not a prime number either. Without even having to do any calculations, as long as I remember my vocabulary, I'm going to be all right. The word product means times. I'm left with 2 possible answers here, and only one of them has got multiply in it, or times, and that's this one here. I can do a double check to make sure I've got the right thing. You'll know if you've selected the right one or done the right thing because when you've got a product of the prime factors, all these numbers circled here for E should multiply together to give your starting number of 72. 2 times 2 is 4. Times by 2 again is 8. Times by 3 is 24. And times by 3 again would be 72. There's a couple of ways you could see it, but you could also imagine it as 8 times 9, which we do know is 72. Okay, question 24. 0.64 divided by 0.2. What makes this difficult is the fact all our values are decimals. Here's a neat little trick. If you get one of these that isn't a multiple choice on a proper exam paper, which in the main GCSE paper, they're unlikely to be multiple choice. You're not going to be given 5 options. You might have to figure it out for yourself. If you scale up both these numbers by the same amount, then the answer will be the same. In other words, if I make that be 6.4 divided by 2, I've basically made both numbers 10 times bigger. It's exactly the same calculation as long as I change both the numbers for division. Again, a counter proof of that, a supporting proof, would be something like 10 divided by 2 equals 5. If I make both of those numbers 10 times bigger, I've got 100 divided by 20, also equals 5. I can keep going if I like. 1,000 divided by 200, also equals 5. As long as I scale up the dividend, which is the first number in a division question, and the divisor by the same amount, then the quotient, or the answer to any division question, will always be the same. We can use that logic and reasoning over here. I've now turned this into something I can do in my head. 6.4 halved, or divided by 2, is 3.2. So scaling decimals up by the same amount, i.e. multiplying both by 10 or multiplying both by 100, could make your life a whole lot easier. That's my recommended tip for that one. Last one, question 25. This question looks like a complete catastrophe. The sort of thing, if you did have multiple choice, you'd really be struggling with maybe. I would try and look at this as just 2 separate triangles, just doing one thing at a time without even reading any of this. I wouldn't even read any of this information. I would look at this picture and I would say to myself, well, this triangle P, Q, and R is an isosceles triangle. I know that because I've got these little marker points there. That means that this angle and this angle are identical. I know my total value of all the angles inside a triangle is 180. That must mean that these two here are worth 130 altogether. If I then divide by 2, I'm left with 65 in each one. If I want, I could add those 3 angles up, the 65, and the 50, and see if they add up to make 180. If they do, then I know I've done my calculations right. If they add up perhaps more than or less than, perhaps I've forgotten to carry a 10 or something like that. I'm now going to look at the other triangle here, and I haven't even read any of this yet. I haven't even read any of it. I'm just going to fill in all the angles and then answer the problem once I've done everything I can with all the information. I like that as a tactic for these complicated angle problems. Fill in everything you know before you even start doing what you're being asked to do. Because if you've got all this information on this table completed, on this diagram completed, you're probably going to be able to answer any question. So that's an advised tactic. Also as well, all of this can confuse you. I've also got another isosceles triangle here, but with 30 degrees already taken up. 180 altogether, let's not forget that. So my first thing here is 180 degrees, take away 30 degrees, which is 150 degrees. Now that's going to be shared between this one and this one. So I've got 150 shared between 2 identical angles. Why? Because it's an isosceles triangle which has symmetry, which means each of those angles is going to be 75 degrees. Now I've found every internal angle in interior angle there, which should be enough for me to answer pretty much any question about this entire diagram. It's asking us what is the size of angle X, which is this outside bit here. Angles about a point add up to 360 degrees altogether. That's all the way around that point. I know 65 and 75 of them already. Which equals 140. That must mean the outside section, the green arrow section, is going to be 360 subtract 140, leaving me with a final answer of 220, which is B.